And then once I have that map of what's the actual distribution for the histogram, there's a lot here. Like I said, I'm going to make this code freely available. What it does is it calls a function that I've created here called setPixel. And what that does is it gets the image. When I said I couldn't remember why I was grabbing the image data, I'm using it here. So the actual image data is an array of basically numeric values which represent the values for each individual pixel in that entire canvas. So if it's 800 by 600, it's an array that contains, I don't know, do the math, that many number of numeric elements that represent the values for each pixel. And so what I'm doing is actually setting at whatever position +0 is a red value, +1 is a green value, +2 is a blue value, +3 is the alpha channel. And so using this, you can very, very, very rapidly iterate over every pixel or in the image, or you can, let's say if I, like I said, 1,000,000 data points, you can iterate over that 1,000,000 data points and just set a pixel value rather than for 1,000,000 data points say, oh, go here and draw a circle. Because if you think about the amount of computational logic it takes to draw a circle and then do it 1,000,000 times, that adds up very, very, very quickly. So that's the 1,000,000 data point example. I didn't create this visualization, but this is the type of thing that you can do with the HTML5 canvas. I just came across this on Twitter yesterday, and let's forget about the political discussion that could go with this because it's gun murders in 2010. But I thought the visualization itself was actually really, really cool. So what you can do is, let's say if we want to filter this by the type of gun, or if we want to say, oh, it's rifle, or we want to say age group, if we want to do children, you can drill into this information. It can be highly animated, highly visual, and this is all done using basically the line tree methods. So that in the HTML5 canvas, you're drawing a line from here, or you're drawing a curve, or whatever you're doing. And basically, this is showing the number of people that were killed by guns and the number of years that were stolen from their lives. Like I said, I want to avoid the political thing, but I thought it was a really good visualization and a really great use of the HTML5 canvas.
Oh, what's the yellow and the white?
The yellow is the number of people killed. The white is the number of years stolen. And you can scroll down and get some more. Whoops. Why is my button not working?
It looks good. It's just not clear looking.
Yeah, it's.
The yellow is the beginning, and that's when the yellow stops, they die.
Yeah, when the yellow stops, they died, and the white is what the projected life expectancy would have been. But I don't know what logic they were actually using to calculate those numbers. I was just looking at the actual visual experience itself. And don't kill me for any politicizing of it, because all I really wanted to do was show a really cool canvas experience. So let's talk about SVG now. How many people are familiar with SVG? Okay, so I don't need to explain every detail about it. I'm done. Okay, SVG, scalable vector graphics. In the age of retina displays, this can be your friend. Because if you're doing things that are based on just images, actually, like take a step back. Like the canvas can be also your friend with the age of retina displays. Because you can have it draw up whatever your device resolution is. But if you compare an SVG to, let's say, a static image, SVG, because it's a vector graphic, it's going to be very crisp, very clear, regardless of what pixel density you're using to view it. Whereas, if you have an image that's at 72 dpi and you view it blown up in a web view that's at 240 dpi or whatever the iPhone is, or the iPad 3, then things get pixelated. But basically, SVG is a declarative vector graphics markup language, so you can use it to create complex vector shapes using text-based input. What's really interesting about this is you can also programmatically create these vector elements in JavaScript, and that's where things start getting really interesting with HTML-based visualization. So. Let me refresh this, because for some reason my browser's doing weird things ever since showing that last visualization. So what we have here, this is actually a chart that was rendered using a charting library called HiCharts. I've used this in multiple applications. And what it does is, based on the data that you pass into it in JavaScript, it creates an SVG graphical representation of that. And if I go ahead and inspect element here, you can actually see the SVG itself. So we've got the SVG shape, and this complex shape is made up of some rectangles, some complex paths, which I'm not going to get into the specifics of SVG specification, but you can set a fill on each one of those, whether it's a solid or you can set colors to it. And then you can set a complex path, which is basically a series of XY coordinates where it's going to draw a vector shape between all those different XY coordinates. We don't need to worry about all of that right now, because I really just want to talk about how you use SVG. They can be created programmatically on the client or the server side, so you can render SVG. SVG files can be static text files. They can be dynamically created on the server side, or you can create them totally in JavaScript, totally on the client side. Where SVG is different than the canvas is that the canvas gives you individual pixels, but the SVG is really more of a coordinate plane, and you're drawing vectors between those different coordinates. And like I said, they can be static or dynamic. Where it starts getting interesting is each individual SVG element is actually part of your HTML DOM. So just like any HTML element that's part of your DOM, you can add things like mouse event handlers to it, like a click event handler or a touch event handler, and then so it can be highly scripted. So if you interact with it, it has behaviors associated with each individual element. Now, if you're doing HTML5 canvas, it's one element. It's the canvas. You draw on it programmatically, and then you have to do any kind of logic yourself. But with SVG, because they're part of the DOM, they have all the functions that an HTML DOM element has. You can do some really interesting things. Before I jump into the examples, here's a couple frameworks that you can use to create HTML-based visualizations. HighCharts is the one that I showed here. Sencha Touch charts. Sencha Touch is a suite of JavaScript-based components for building applications. They have a charting component to it. Kendo UI is another user interface components in JavaScript. They have a charting component too. Google Charts, so not the Google image charts, which I mentioned earlier, which are just images, but the actual Google Charts are basically they render SVG. There's, oh, I forgot a comment here, but D3 is a really, really interesting data visualization framework. D3 stands for Data-Driven Documents, and people have really been pushing this a long way to create very highly interactive, very visual, very rich types of experiences. And I think, did you guys already have a presentation on D3? Or,
Christian? 2 months ago.
Okay.
It was map focused.
Okay, so it's map focused, but you can do a lot of really cool things with D3, and there's a lot of examples in their samples that focus on SVG-based visualization. I'm going to show a couple of them in a minute. Another really good library is, there's Raphael.js, which is a library focused just on SVG, and there's Raphael, or what, I can't pronounce it, I'm butchering that, but it's g.raphael. I don't remember what the extension is for the website, but basically it's built on top of the Raphael.js framework, and it's totally based around charts on the Raphael.js library. Now, I really like this visualization. I didn't create this one, but if anyone else likes James Bond movies, you might like it also, or you might just think it's a cool looking visualization. But basically, each element that's in here, I can mouse over individual elements and have events. I can, I say I, but I'm using that figuratively. I didn't do this. But it's a great visualization. So each one of these elements is actually a piece of SVG. Whether they're parts of vector shapes, even everything down to, I believe, each little icon. So in the markup language, it describes all the XY positions for drawing paths to create all these complex shapes. Where it's interesting, where I said each element is scriptable. So each icon or each piece of the chart, you can attach behaviors to it, like a hover behavior or a click behavior. And so that's what's happening when I move the mouse here and it's animating the different pieces, and it's basically just a hover event over the DOM element, triggering some JavaScript, which causes the content in the bottom here to be animated out. Oh, the old content animated out, new content animated in. What's also interesting is that because they're elements in your DOM, you can use something like jQuery, and let's say if you want to programmatically change values in there. So if you wanted to animate the actual chart itself, basically you're just animating properties of the DOM. And so you can create some really interesting, really visual type of examples here, and the code behind this is comparatively not very complex. So that's an example of what I think is an interesting SVG-based visualization. Now I mentioned D3. This is an example straight from the D3.js examples page. You can do some really cool things. Like, so if I'm selecting this one area, it highlights all the different data points in different views for, the information that's contained within that chart. Jump to another one. Sankey diagrams, which I haven't worked with these that much myself, but it's my understanding that they map the flow of energy from one source to another. I just think they look cool, and it's a great example of an SVG-based data visualization. But because I can have actions on individual elements, so individual quote-unquote DOM elements, then I can attach behaviors to them, whether it's changing color when something's highlighted, or whether it's on a click event, I'm having it respond to different events, like I can drag it and I can move things around. And this is one of the examples on the d3.js website, so you can download it, check it out, and get started with it, and start building your own applications on top of this. I thought that was a really good one. Here's another example, bullet charts, which are basically a variation of just a bar chart, but you can see that there's different pieces on here, lots of different lines that represent the different values, but when I hit update, they're animating. Basically, these are just parts of the HTML DOM that are being animated. Well, the SVG components within the HTML DOM that are being animated, and give you that interesting visual type of scenario. So, we talked about Canvas, we talked about SVG. I didn't go into too much code with SVG, but I definitely highly recommend checking out the SVG visualization libraries, because they abstract some of the tedium and the complexities of SVG away from you to make it easier, and you can focus on building the interactive experience as opposed to building, declarative SVG markup. So the next thing I want to talk about is HTML DOM. And, when I talk about HTML DOM, I'm talking about the creative use of standard HTML elements to create something that's a little bit more visual. Now, when I talk about this, there's one usage scenario that I like to show first, because when you kind of step back and you break down all the different components, you can understand what I'm talking about. Where I'm saying it's just HTML DOM, the regular HTML elements. And if you already did a data visualization or a meetup on maps, where are my map tiles? Come on, network. There we are. Has anyone written an interactive tile engine before? It's really fun to do, I will say that. But basically, the way that all mapping works, I say interactive mapping works that are built on top of a standard HTML and JavaScript interface is there's basically a div, an HTML div. Inside of that, there's a layer where there's a lot of image tags. Each one of those image tags has a basically set of geographic lat-long coordinates that are associated with it. Now, you can, just by taking the lat-long coordinate, if you have all the algorithms that are associated with it, you can determine how a pixel on an XY plane corresponds to the lat-long value. And from that, you can determine which actual just plain old pictures, just images, do I need to line up to create a greater composite that is actually something that is much more meaningful than just a couple of pixels on the screen. So if I go ahead and zoom out here, you can see that the tiles are loading in, and you can see what I'm talking about. So that when each individual square lines up, they're actually it's just an image, that's all it is. And there's creative use of JavaScript in order to, one, add interactivity to it, so that when I click and I drag and I pan, we load in more images from one side to the other, or depending upon the direction that you're actually dragging. Or, excuse me, is there any water back there?
I get some.
All right, I've run out. But basically, we have all the different images that make up the composite, but then we're also just using JavaScript to add interactivity to they're just standard HTML elements. Now, if we wanted like point and polygon overlays, or if we want images overlaid, they're really just standard HTML elements. Now, granted, if we're doing directions from here to here and we want to follow every street, well, maybe we use SVG or something like that, which, for all intents and purposes, yeah, it's vector graphics, but it's part of the HTML DOM. But if we just want to put a marker that represents, every Starbucks, which the map would be probably totally covered. If it's a Starbucks, so it's just an image. So I think maps are a great example of using just pure, plain old HTML elements for an interactive data visualization scenario. And now what's also great about this is, I've been talking about HTML5 and how it adds interactivity and graphic support. These are HTML, I don't know, probably 3 compliant. It's just standard HTML DOM elements. Thank you very much. So, with that, let me go ahead to the next one. Now, this is actually a screenshot. I don't have the live one up and running right now. Of an app that I was on a team, we created it, and it's for visualizing CRM information. And this is all just totally fake data, so it's okay. But it's actually being used inside Adobe. And we created it so it can be used in the desktop browser, but it's also a PhoneGap app, so it can be used and natively installed on both Android and iOS platforms. Now, all of the elements that you see here, everything from the interactive slider to the bars, and there's multiple little colored sections in each bar, everything is just plain old HTML. The way that this works is, and I just realized I'm talking into the wall. Can you guys hear me? Okay. Let me try standing over here and talking this way. But basically, this is just an HTML table. Actually, not even just a table. They're div elements with the CSS style of table row and table cell. So this is a table row, and in that table row we have multiple cells. We have one here, and then we have one here. And then inside this there's a div that has, based upon we know the data range. It goes from 0 to I think it's 1.3 million, and that's dynamic based upon all the data that comes in. But we can calculate for this data point, and this, by the way, is all rendered client side. But basically, for this range, and we know that this data point is only $100,000, so we can say, what percentage is 100,000 of the total range, which is 1.3 million? So we calculate the percent, and then all you have to do is use CSS styles to do a percent-based width on this div right here. And so the corner rounding is just CSS3 corner rounding. You might be able to see on some of these, there's actually a stripe, and there's obviously the bevel on the edge. That's all just in a CSS background image that's repeated horizontally on this HTML div. And so inside of that, actually not even inside of it, but inside this same container, there's another div which represents the smaller colored bars. And so for that, it's using the same technique. It's just using a percent-based width based upon the total range, and it's got CSS styles applied to it to set the different colors, the colors and the patterns. And so I wish I still had it up and running, but it's actually hooked into Salesforce, and anyone who's ever worked with Salesforce knows that once something goes live and you're a developer, you can get locked out of it. So that's why I don't have it up and running. But basically, all of it's dynamic. If you move the slider, it changes the values that are used to calculate the small bar. So as I'm sliding in real time based on JavaScript, it's just updating the width of these, and so they move back and forth and size. And it's a very rich, very visual, and very polished looking data visualization type scenario, but it's just plain old HTML div elements and CSS styling. So that's all that it is. And again, I talk about HTML5. There's nothing about this that's HTML5 except for the CSS rounded corners. That's it. So I wanted to take that same example and break it down to a really, really simple one. What I've got is a bar chart and a column chart. And all these are just HTML div elements. And let me actually go ahead and jump to the code for this one. So where did I put it? Dot chart. So basically, for each bar in the bar chart, I have a div element. Well, I have a couple wrappers on there just to get things so that they line up correctly and they display correctly. But for each one, it's just using the positioning of the browser, so it's div, and div below div below div. And then I'm just setting a style, a width. So this one's 80%, this one's 70%, this one's 50%, this one's 60%. They're just percent-based widths on divs. And you can either use the default browser spacing to stack them vertically or horizontally or whatever, or you can use CSS positioning, so fixed position, so it is in a certain XY position, or if it's whether it's top, bottom, left, right position, you can say, oh, it's always going to be X pixels from the left side, and it's always going to be Y pixels from the bottom, and then the percent, the height is percent based upon whatever data, how you want to render it, how you want to process it. But the root of it that I'm trying to get to is that there's nothing special about this other than it's a creative application of just standard HTML div elements. Any questions at this point? You guys have been quiet. Yeah?
What's the advantage of using standard HTML elements for, say, SVG? I can think of one way to disadvantage.
The advantage is that one is, well, I would say two advantages, and I would say any one of these, there's pros and cons to all these. But the advantages, I would say, is that it runs pretty much everywhere. If we take Android, for example, if you go back to Android 2.3, I think is where these issues, after 2.3 it starts getting better, but 2.3 is the most predominantly installed version of Android on all devices on the planet. Android 2.3 doesn't render SVG. I think it has performance problems with Canvas, but it can render standard HTML just fine. So it would be, the one advantage is an approach like this is supported in more places.
The counterpart to running everywhere is running slightly different everywhere, right? So you're going to have to work around quirks in the implementation, affect different platforms.
Well, and that's one of the things with web development in general. Unless you're locked into a particular browser, you say, oh, we're only going to support Chrome, we're only going to support IE, you could run into that pretty much anywhere.
For SVG and Canvas as well?
Well, for SVG, yes, because it's not supported on older Android platforms, but it's supported on newer ones.
But when it is supported, it's supported consistently?
Yeah, I would think so. I say that there's probably some caveats there that you will never find out until you're deep in development and it's midnight and it's due tomorrow. What's wrong? Okay. No one's experienced that? Come on! But yeah, I would say as far as benefits to each one, it really depends upon the use case, what platforms you're targeting, how you want people to interact with it. Do you want each element to have events applied to it, or do you just want the canvas and you just want the visual representation? How much control do you want over it? Because while this is really easy and you can render it pretty much anywhere, you don't have a lot, or it's not as easy to create something that's as customized as you can create with SVG or with a canvas.
But it works everywhere.
Yeah, but it works everywhere.
Work everywhere.
The rounded corners work the same everywhere?
Well, no.
the rounded corners, yeah, that's one part of it. But if you just want the meaning expressed through the visual component, and all you truly care about is it the right width for whatever range I'm trying to project, then yeah, that does work absolutely everywhere. Somebody had a question over here, I thought, but okay.
Well, mine is pretty general. I just wanted to know what you thought the difference was between charting and data visualization. For you, software changing it, I just think there's a...
So, I mean, I think charting is a component of data visualization. Where data visualization, and I come from a developer background, not from like an information data visualization type background. I just am fascinated with trying to get visual information on the screen. But charting is just, it's a chart. It's a way to get data up there that, they're common visual paradigms that people can easily look at and understand. But the data visualization part of it is, how does it all work together? And how does this meaning, how is this visual piece actually conveying meaning to who's ever using it or who's ever consuming it? I might be totally way off on like the textbook definition of it, but that's what I interpret.
Sounds good to me. Actually, we have a new member. I'm not sure if they're here tonight. They said that their definition of data visualization, we've had a million of these, almost all of you have answered this question, but I liked it in 2 words. They said it was cognitive ergonomics.
That's a good one. You had a question also?
So, before when you talked about Edge Animate, the HTML versus ActionScript-based language apps for Adobe, how does that compare to Create.js?
So, conceptually, they're trying to do the same thing. Create.js toolkit is based upon HTML canvas, and so how it ties into Flash Professional. So if anyone doesn't know what I'm talking about here, Create.js is a library in this Create.js toolkit that you can use to create interactive experiences using Flash Professional and export them out to HTML as the runtime. But yeah, Create.js is based on Canvas, where Edge Animate, you're actually animating DOM elements. That's the biggest difference between the two of them. Other than that, they're both timeline-based animation tools, and they have a lot of really similar paradigms. There are definitely differences between the two of them, but that's, I'd say, the most fundamental difference is just one's Canvas, one's DOM.
Okay, because actually the timeline functionality is what makes Flash stand out. Because if you have to hard code animations, it's really technical.
Edge Animate is, I don't want to take too much time. I could fire it up and do all this, but I don't want to take everyone else's time. But basically, it is a timeline animation tool. It's intended for designers, not developers. So the drag and drop, you move your position on the timeline, and you can animate things, move them around. It's free to download and try it out if you haven't already. But yeah, that's just the biggest difference is Canvas versus DOM. All right, so I don't even remember what my next one. Oh yeah, WebGL. WebGL is really exciting because it's hardware accelerated. You have a question?
Yeah, sorry, I had a last question. I'm really interested in BI solutions, especially ones that are connected to, for instance, SAP systems or Oracle databases, or in general ERP solution, enterprise solutions. You
Okay.
mentioned Salesforce previously.
Yes.
Do you guys at Adobe, do you have any prepackaged solutions, or is it run, for instance, mobility applications?
So we don't necessarily have prepackaged like components or visualization pieces for Salesforce, but Salesforce, their hybrid SDK, which hybrid meaning HTML mobile SDK for natively installed mobile, is actually built on top of PhoneGap, which is it's Adobe open source PhoneGap is Apache Cordova, but it's the tools that you can use to build natively installed apps on like iPad or whatever tablet or phone using HTML-based technology. So any of the libraries that I'm talking about here can actually be used to render Salesforce data inside their mobile hybrid SDK, if that makes sense. The Salesforce is like a unique one. They have a native SDK, and they have a web SDK, and then they have a hybrid SDK.
Salesforce.com and everything like that. But with regards to ERP solutions, for instance, SAP, SAP is pushing out their mobility solutions.
Yes.
It's going to be a big thing. So do you have any solutions that can, in an easy way, fast? It has to be fast, cheap, and look pretty and be nice.
I'd say we don't necessarily have like pre-built components. There's a lot of third-party vendors that do those kinds of pieces. But Adobe does have a partnership with SAP to also leverage PhoneGap for hybrid mobile applications. So basically the same way that Salesforce does it, Adobe has a relationship with SAP for the exact same kind of situation. And let me get my iPad real quick, and I can show you kind of what I'm talking about. I'll just do one of these show and tell kind of situations, but let me pull one up here. If I can get my password right. There it goes. So this is not an SAP app. I can't show it because I don't have this going through the network. But basically, this is an app. It normally has charts here, but I'm not connected to the network, so I can't do it. But all the charts are actually rendered using the same charting library, so it uses high charts. Charting library that I'm talking